Hi everybody, in this video I'm going to go over the Regents Review number 2 assignment. So in number 1, it's asking us which pair of corresponding parts and methods would not prove the triangle's congruent. So if we go through it choice by choice and test it out, we can see which one does not prove them congruent. So our givens were that this angle and this angle A and angle EDF are congruent. And we already know that AB is congruent to DE. That was already given as well. So now let me try out answer choice 1. AC congruent to DF by SAS. That's true. We have side, angle, side, angle, side. Let me backtrack. That's not the choice we're looking for. Okay, BC is congruent to EF and SAS. For SAS, the angle needs to be directly in between the two sides. What I have here is actually ASS, which is a bad word. It's not a method of proving triangles congruent. If you go the other way, SSA, that's the same thing as ASS. It's just written backwards, and it's not a valid method. So this is the correct answer. It is not SAS. If you try out answer choices 3 and 4, you will see that if you put in angle C congruent to angle F, it will give you AAS. And if you put in angle CBA congruent to angle FED, it will give you ASA. The next one is asking which statement is always true. So let's take a look at what the givens were. So FE bisects AC at B. So if it's bisecting AC, it's splitting AC into two equal parts at where it's bisected. And GE is bisecting BD at point C. So BD is being split, I'll just use one blue, is being split into two equal parts at C. So what I can see here just from marking my givens is that this is congruent to this, and this is also congruent to this. So that means that everything marked here is congruent to each other. If AB is congruent to BC and DC is also congruent to BC, then these two things have no choice but to also be congruent to each other. And that's answer choice 1, that AB is congruent to DC, and that's the transitive property. If two things are congruent to the same third thing, then they have to be congruent to each other. All right, moving along. So you guys have a constructions packet that you did for Regents Review 1. This one over here is the correct construction of an altitude. An altitude construction is, so an altitude is a perpendicular line that passes through the vertex of the side that it's drawn to. And the steps for the construction are that you put your compass on the vertex and you make an arc that hits the side of the triangle in two spots. So this would be like, this is a perpendicular bisector connected to the opposite vertex. This would be a median construction in the first one. This one over here is trying to be an altitude, but the arc needs to pass through 2 points on the side that's opposite to the vertex. And this is just a perpendicular bisector. So 2 is the option here. So based on your constructions packet, a parallel line would be, we construct it using the first method, but just to give you an idea that there's many different ways that you can do constructions for them to be accurate and valid. This one's specifically asking you for a way that uses congruent alternate interior angles to make those parallel lines. So this first one, the way that we usually do, makes corresponding angles because we copy the angle from here to here, so it makes corresponding angles. This one over here, oops, is the only one that has alternate interior angles. Look at that backwards letter Z. So that's number 2. Oh wait, no, that's number 3. Sorry, it doesn't match up. I give credit if you circled the picture as well because it doesn't like line up exactly. Okay. So over here in the next one, we have AB is parallel to DEF. Angle B is 43 degrees. That's 152. Which statement is true? So let's see. These are supplementary. So 180 minus 152, that is 28 over here. And we have parallel lines cut by a transversal. So we have alternate interior angles. So this would be 43 degrees. 43 plus 28 is 71. And since all angles of a triangle add up to 180, if I do 180 minus 71, I got 109 for here. So that gives me 109 for here. And let me just check out the last angle. So 109 plus 43 is 152. 180 minus 152 is 28. So let's check out which is true. Angle D is not 28. Angle D is 43. Angle A is not 43. Angle A is 28. Where's BCE? Oh, I'm up to ACD. Sorry. ACD is right here. These two vertical angles are 109. So if I do 180 minus 109, so that is true. Okay, moving on. So the easiest way to do this one, you could do it by using the formula n minus 2 times 180 and finding all of the interior angles, since you know that all the interior angles of a pentagon do need to add up to 540 degrees. But I prefer to do it with exterior angles because all exterior angles of any polygon always add up to 360 degrees. So I have this 140. I can get the exterior angle next to it by subtracting from 180. That would give me 40 degrees over here. I already have that exterior angle. I already have that one. So I have 1, 2, 3, 4 exterior angles. So I'm going to add them up. 40 plus 60, just the outside angles, the exterior angles, plus 84 plus 68. And that is 252. Now, since all the exterior angles of any shape add to 360, 360 minus 252, let's see what that is. And that is 108. So that gives me 108, and that is what I'm solving for. So that is the answer. And there's multiple ways to doing this question, but that's the easiest way. Okay. Let's move on to the next one. I am unable to see it. Let me pause the video. Here they are. Okay, so we have median BF in this question, and a median does connect to a midpoint. So BF is the midpoint of this line segment. So from A to F and from C to F would be congruent segments. And that's my answer right over here. Okay, so I already found my answer. I also, just to talk about why the other ones are not right, BE bisects angle ABC. So angle ABC is bisected by BE. So from BE to this end and BE to this end, that would be the same. So that's ABE, not ABF. And CBE, not CBD. And then you can check out the other two. They're incorrect as well, but I feel like most people would have probably. Okay, moving on to the next one. Isosceles trapezoid. Remember, diagonals are congruent in an isosceles trapezoid. So if one diagonal is 5x plus 13 and the other one is 11x minus 5, all I need to do is set them equal to each other. And if you solve for x, you should get 3. Moving along. So if you take a look at your constructions packet, the construction here is angle bisector. I gave credit for 1 or 2, but 1 is the correct answer because I gave both of them because they both talk about angle bisectors. But the correct answer is angle 1. An inscribed circle is inside a triangle. And like inscribed is inside the triangle. I gave credit for both of them because they both mention angle bisector construction. I can't see 10 for some reason. Let me pause the video and paste that in. Okay, I don't think there was anything in that spot. So let's take a look over here. What we know is that the triangle itself is isosceles. So two equal sides, remember that also means two equal angles. That might be important. We know that AB is congruent to CB and that all these segments here are angle bisectors. So they're splitting the angles in half. So they're telling us that angle BAC, this whole angle here, is 50 degrees. So since this is an angle bisector, that means each half is 25. And since this is an isosceles triangle, not only does it have two equal sides, the base angles are also equal. And since it's being bisected, it's once again 25. So 25 and 25 is 50. And that leaves this last angle of the triangle to be 130 degrees because all the angles of a triangle always make 180 degrees in total. So 130 plus 50 makes the whole 180. Okay. So angles of a triangle are in the ratio 2 to 3 to 4, and they all add up to 180. That's 9x is equal to 180. So x is equal to 20. We want the largest. That would be the 4x part. So I'm going to replace x with 20, and that would be 80 degrees. We are given that WY is congruent to XZ. Those are pretty long segments. And we want to get information about WX, which is shorter than WY, and YZ, which is shorter than XZ. So already I see that we're making things shorter. That's going to be subtraction, not addition. If we were going to be subtracting, we would be taking WY and subtracting off XY to be left over with WX. If we were subtracting here, we would take XZ and we would subtract off XY to be left over with YZ. Since we're subtracting off XY from both this segment and this segment, we would need to know it's congruent to itself by the reflexive property in order to do that subtraction. Remember, when we subtract, we start with congruent and we subtract congruent, and that's how we end up with congruent. Moving along, this is H out, right triangles, congruent hypotenuses, and a pair of congruent legs. This is ASA, this is AAS, and this is ASS or SSA. That's not valid. A is the correct answer. Okay, for 15, let me get my compass out so I can do this one super quickly. I'll just wait for my compass to appear on my screen. I don't know where it went to. Okay, I found my compass. So I want to divide this into 4 equal parts. So for 2 equal parts, I can cut this line section in half with a perpendicular bisector, open up any length about 3/4 of the way down, and just make an arc that goes above and below. And then what I want to do is, without changing the distance that my compass is open to, I want to just go over to the other endpoint, and I want to make the same arc above and below using that same compass point. So what I did now, let me just draw my bisector in through the intersection points. So what I just did right now is I cut my line segment into 2 equal parts at this midpoint because it's in half right now. So if I want to cut it into another 2 equal parts, another 2 here and another 2 here to make 4, I would just need to bisect this half and bisect this half. So that's exactly what I'm going to do. I'm going to take my compass and I'm going to put it on one endpoint here. And I want to open up about 3/4 down the line segment. That looks like about 3/4 down this line segment over here. So I'm going to make an arc that goes above and below. Then I'm going to go over to the other endpoint without changing my compass length. I'm going to make the same arc. Oops. I keep clicking everything that I shouldn't be clicking. And right through the points of intersection, there's my bisector. And I'm going to do the same exact thing from this to the segment over here, from the midpoint to the other endpoint, about 3/4 of the way down, an arc above and below. And then, without changing the distance that my compass is at, I'm going to go over to the other endpoint, and I'm going to make the same arc. And there we go. So now what I have here is I have 4 equal parts of my line segment. Let me show you those 4 equal parts. I have from here to here, that's 1 part. From here to here, that's a 2nd part. From here to here, that's a 3rd part. And from here to here, that's a 4th part, because these are all midpoints. So we have 4 equal parts. So what I did is I just cut the line segment in half, and then I just cut each of the halves in half, and that's it. Let me get rid of this compass here. I can move on to the next question. There we go. I gotta get rid of my compass up here too. A million compasses on my paper. There we go. Okay, moving down to the proof over here. This proof is not too complicated, so I'm not going to write my givens down, but you need to write your givens down if you're writing a proof. You will lose points on tests and the Regents exam if you do not write your givens down. Just to save time on this video, I'm not going to. You do need to get full credit on proof questions. C is the midpoint of BD and AE. A lot of people marked this in the diagram and did not put it in the proof. So let's do that. AC is congruent to CE. BC is congruent to CD. Midpoint splits a line segment into congruent parts. No definition of midpoint. I took off points for that. I will not give you credit for that on a test. I will take off points. Write out what the definition is. We have vertical angles. These are not the same angle. They are 2 separate angles in 2 different triangles. That's why we do not use one letter name. If you write down angle C congruent to angle C, first of all, that's right because they're not the same angle. Second of all, that might make you for the same angle, which is why we need to use letter names. If we use 3 letter names, A, C, B, and I'll call the other one D, C, E, notice that the letters are not the same. The only letter that is the same is the vertex C. They're not a shared angle. So I'm going to write here, intersecting lines form congruent vertical angles. From here, I know my triangles are congruent, so triangle ABC is congruent to triangle EDC, and the reason for that is side angle side. I'm going to continue my proof over here. So I'm trying to prove the lines parallel, and I see that I have alternate interior angles here. So I don't know they're congruent because I don't know the lines are parallel. They're only congruent if the lines are parallel. But if I can show the lines are parallel, if I can show that the alternate interior angles are congruent, that will help me show the lines are parallel. So now that I know the 2 triangles are congruent, I actually can say that angle A is congruent to angle E. It's not because they're alternate interior angles, because we don't have parallel lines. It's because the triangles are congruent, so the corresponding angles of those triangles are also congruent, which is CBCTC. Now that I know that these angles are congruent, now I can go ahead and say that AB is parallel to DE. And the reason for that is if alternate interior angles are congruent, then lines cut by a transversal are parallel. Some people worded this incorrectly. They said parallel lines cut by a transversal make congruent alternate interior angles. That's true, but that's not what you're trying to say here. You're not trying to say the alternate interior angles are congruent because the lines are parallel. You're trying to say, I already know that we have congruent alternate interior angles. That's how I'm proving, that's how I'm showing that the lines are parallel. You want to say that because the alternate interior angles are congruent, that makes the lines parallel, not the other way around here. Okay, moving on to the next proof. And I'm just going to do it over here on the side. Once again, I'm not going to write my givens. You need to on a test. So AB is perpendicular to BC. DE is perpendicular to EF. So a lot of people were not writing the right angles down in their proof. Did you need to say that angle B and angle E are right angles? And there's no confusion here as to which angle those are, so I'm just using one letter names. But when in doubt, use three letter names for angles. And the reason for that is perpendicular lines form right angles. Because again, we did say we have perpendicular lines. And now I actually need to say that congruent to each other. And the reason for that is all right angles are congruent. I also know that BC is parallel to FE from the givens. So I do have a letter Z. So I do have congruent alternate interior angles. I'm going to say over here, angle BCF is congruent to angle EFC. And my reason for that is parallel lines cut by a transversal make congruent alternate interior angles. The last thing I have in my givens is AB is congruent to DE. So I have enough information to say that my triangles are congruent. I have AAS, AAS. So I'm going to say here, triangle ABC is congruent triangle DEF. And my reason for that is AAS. And now AC is a full side of triangle ABC. DF is a full side of triangle DEF. So no need for addition. Those are full sides already. So I can just say AC is congruent to FD by CBCC. They are full sides of those triangles that I just proved congruent. Not pieces, they are whole sides. Okay, moving along. Explain why angle NLO is 40 degrees. Explain means in words. So I can say here, so I know this is 118, and then I know since angles of a triangle add to 180, this has to be 40. Since opposite angles of a parallelogram are equal or congruent, angle O is 118 degrees. Now I'm just typing quick. Since all angles of a triangle add to 180 degrees, angle NLO is 40 degrees because 118 plus 22 is equal to, let me count my calculator out, 118 plus 22 is equal to 140, and 180 minus 140 is 40 degrees. And that would be a perfectly good explanation. I mentioned how I knew this was 118 and how I knew this was 40 degrees. So basically, any measurement that you're referring to, just explain how you knew what that measurement was, what property of parallelograms you used, or what property of a triangle you used, how you got that measurement that you're using to get to your answer. Number 20, a lot of people lost a lot of points on it. There's many different ways to go about it. I'm just going to move it somewhere to where I have some more space. Actually, no, because I'm not going to actually write the whole thing down because that's going to take way too much time. And there's also multiple approaches for this question. So keep in mind, you need to first prove that you have a rhombus. And before something can be a rhombus, it needs to be a parallelogram. We have many ways that we can prove that we have a parallelogram. You could show opposite sides are parallel. You can show that both pairs of opposite sides are congruent. Those are two main ones. To show opposite sides are parallel, that would be slope formula. To show opposite sides are congruent, that would be distance formula. After you show it's a parallelogram and you put a reason why, you put a concluding statement, this is a parallelogram because both pairs of opposite sides are parallel, then you can show it's a rhombus because you already know it's a parallelogram. And remember, one of our ways that we can show that we have a rhombus is by showing that all the sides are equal. So it's enough to just show that two sides next to each other are equal. Because remember, if a parallelogram has congruent consecutive sides, it's a rhombus. All the sides are equal. So if you just pick any two sides next to each other and you use distance formula and you show that they have the same length, then you know it's a rhombus. Put the concluding statement, this is a rhombus because it has congruent consecutive sides. Then, since you're proving it is not a square, you need to show it's not a rectangle. Because if it's not a rectangle, it can't be a square. A square is both rhombus and rectangle. So a main way to do that is, well, one way you could show that the diagonals are not congruent. That would be distance formula on the diagonals. Another way is you can take any two sides next to each other. You can use slope formula, and you can show that you don't have right angles. Because remember, right angles would be negative reciprocal slopes or opposite reciprocal slopes. So if you don't have any opposite reciprocal slopes, then that means that you don't have any right angles. You don't have any perpendicular lines. And once you show that it is a rhombus, but not a rectangle, then you'll know it's not a square and that Jim is correct. You need to put a concluding statement. On the Regents exam, they take a lot of points off. You'll get like half credit on the question if you don't have a concluding statement. Your concluding statement needs to explain in words what your calculation showed. How you know it's a parallelogram, how you know it's a rhombus, how you know it's not a rectangle, what you showed. Some people are forgetting that when you have a coordinate proof, you actually need to show your formulas and your calculations. You can't just write down it's a rhombus because all the sides are equal and not actually do any work to show that. You can't say it's not a rectangle because it has no right angles, but not do any work to show that. So you actually have to show your work. I know there wasn't a lot of space here, but feel free anytime to attach a separate piece of paper.